stones. At that point of time, when this calculation was came into the scientific community, that the calculation was in terms of GJ. So when the calculation is in terms of GJ, we are assuming there is an assumption that L and S vectors are coupled. Coupled means that motion of the orbital motion of an electron influences the direction of spin. This is said to be coupling. So the trajectory or the path of one is affecting the motion of the other. This is said to be coupling. The point is that at that point of time, Stone was another theoretical material scientist. So he did it for the theoretical calculation was compared with the experimental results. The above calculation of magnetic susceptibility was then compared with experimental results. And in the periodic table itself, for 3D group elements, 3D group elements. So for 3D group elements, that is transition metal ions, transition metal ions. So for transition metal ions, 3D group elements, I remember scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, कॉपर एंड जिंक। आप चेक करके देख लेना, ये 10 एलिमेंट्स है 3D ग्रुप में, इसको हम लोग ट्रांजिशन मेटल आयंस बोलते हैं। सो फॉर द ट्रांजिशन मेटल्स आयंस इटसेल्फ, for the gaseous system, in the gaseous state, this value of magnetic susceptibility was not in agreement with that of transition group elements. So that made people to think, scientists to think, that why it is like this. They cross-checked all the calculations. The calculation, the values were right in their sense. There was nothing wrong in the mechanical, or I may say technical calculation part. Nothing wrong in it. So the point is that this value of magnetic susceptibility is not a universal accepted solution for all type of periodic group elements. Likewise, Stones did it for the transition group elements, and he observed that the value is not correct. There is a discrepancy between the theoretical calculation and the experimentally observed result. So the point now is that why it is like this. Now see, L and S vectors are coupled. So when you say L and S vectors are coupled, that means we say there is a strong spin orbit coupling. आप अगर किसी किताब को फॉलो करेंगे, अगर किसी बुक को आप फॉलो कर रहे हैं, so you will come across this term spin orbit coupling, and you will also come across this particular term when atomic physics will be introduced in your class. So the point is, people started to think about that it is may not be that in all type of systems there is a strong spin orbit coupling. There may be some of the instances, situations where spin orbit, the motion of spin, the fluctuation of the spin in an electron is independent of its orbital motion. That means there is no strong spin orbit coupling. And that was the case for the 3D group elements. So for the 3D group elements, this experimental, this calculated discrepancy all came out, all erupt out. Why? Because that there is no strong spin orbit coupling. So the situation is there is no strong spin orbit coupling. That is the motion of, that is the spin fluctuation of a valence electron. The spin fluctuation of a valence electron is independent of its orbital motion. तो देखो होता क्या है, हम इसको डायग्रामेटिकली आपके सामने एक्सप्लेन करेंगे. Suppose we take a nucleus position, then some kind of distortion is also there. So when there is fluctuation of this electron cloud in an orbit, this I have discussed many times, it gives rise to current I. Why? Because there is variation of charge with respect to time. And if this Q, this fluctuation of Q, dQ by dt is not uniform, there is instant continuous change of the charge with respect to time t, then actually it gives rise to an electronic current I, which becomes a function of time t. And if this current I, electronic current I, becomes a function of time t, it gives by Wyatt-Savart law, it gives rise to a magnetic field B. So it is this particular magnetic field B which is there throughout an internal field for the motion of the electron throughout its trajectory. It is this magnetic field B which creates an additional energy for the orbital motion to get synchronized with the spin direction, to get synchronized with the spin direction, to get coupled. That means they follow a synchronism. That means if a particular orbital motion is at this point and spin is along this, then for this point the spin will also change accordingly. There will be a definite pattern for the orbital motion with that of the spin. So now continuing with our discussion of this particular point, that magnetic field B which give rise to the spin orbit coupling, spin orbit coupling. Sometimes or the other, what happens? That this magnetic field, the fluctuation in some of the elements may not be very strong. That means this rate, the non-uniform rate is not high. So if it is not high, then current I, which is a function of time t, is also not very large. If that current I is not very large, that fluctuation is not very high, then the magnetic field being created is also not very high. So there is no particular external effect or internal effect which is responsible to bind or synchronize or couple the orbital motion with that of the spin motion. So what happens is that orbital and spin motion independently process. Am I audible? Am I
Yes,
audible?
yes,
Yes,
sir.
sir.
Yes, sir.
Okay, fine, thank you. So the in this kind of situation, when the internal field, when the internal magnetic field is not strong, L and S vectors independently process independently with respect to the nucleus of an atom. So you will learn in detail about that. For the case of some material system also it may be possible that spin orbit coupling is not strong. What happens is in that case, the lattice positions, there is particular charge, particles are there, say NaCl. So Na will have some definite position, Cl will have some definite positions in the crystal lattice. So what happens is that the electric field being created by these lattice ions is strong enough to overall neutralize the effect of the internal magnetic field B. So L becomes independent of S. There is no particular energy, there is no effect, electric or magnetic field, which can sustain or couple orbital motion with the spin motion. So in that situation also it happens. Clear? That is said to be ऑर्बिटल मोमेंटम क्वेंचिंग। तो हम इतना डिटेल में अभी आपके साथ नहीं डिस्कस कर रहे हैं। उस फेनोमेना को बोलते हैं, जिस तरह के मटेरियल्स में ये फेनोमेना ये ऑब्जर्व किया गया है कि LNS कपलिंग इज स्मॉल, दैट इज सेड टू बी क्वेंचिंग, QUENCHING। अगर आप गूगल में क्वेंचिंग का सिनोनिम्स देखेंगे, गूगल में क्वेंचिंग का मतलब देखेंगे, व्हाट इज द मीनिंग ऑफ इट, तो आपको मिलेगा सेटिस्फैक्शन ऑफ थर्स्ट। जैसे मुझे अगर बहुत प्यास लग रही है और मैं अभी 3 ग्लास कंटिन्यू पानी पी लें, तो आई विल से आई एम क्वेंच, माई थर्स्ट हैज बीन क्वेंच। माने अगर किसी इंग्लिश के स्टूडेंट को, किसी ह्यूमैनिटीज बैकग्राउंड के स्टूडेंट को अगर मुझे समझाना रहे कि क्वेंचिंग का मतलब क्या होता है, तो हम उसको इस तरह से समझाएंगे कि सपोज मुझे बहुत, आई एम वेरी थर्स्टी, मुझे बहुत प्यास लग रहा है और हम कंटिन्यू एक फ्लो में 3 ग्लास पानी पी लिए, सो आई विल से दैट माई थर्स्ट हैज बीन क्वेंच्ड, दैट हैज बीन सेटिस्फाइड, माई थर्स्ट हैज बीन सेटिस्फाइड। सो एटॉमिक फिजिक्स में, साइंटिफिक कम्युनिटी में इसको बोलते हैं क्वेंचिंग। क्वेंच मतलब ये कि आप जितना भी चेंज कर लो, आप जितना भी, सपोज आप इसमें डोपिंग कर लो, किसी तरह का कोई मैग्नीशियम से डोप कर दिए NaCl में, तो Mg कहीं पे आ गया, लेकिन इन सब के बावजूद ऑर्बिटल मोशन का स्पिन के साथ किसी तरह का कोई पैटर्न नहीं फॉर्म कर रहा है उनके मोशन में। सो वी विल से दैट ऑर्बिटल momentum is quenched, it's satisfied, it is complete, you cannot change, you cannot do anything to it। हम 3 ग्लास पानी पी लिए, अब अगर मुझे जबरदस्ती पानी पिलाया गया, so I will vomit that water। Point is this, my thirst has been quenched, it has been satisfied, so it is said to be quenching phenomena। अब अगर इस तरह का सिचुएशन है कि LNS कपलिंग नहीं हो रहा है, and they are independently processing, they are independently in motion, L का motion, say this is nucleus, this is L, so about that spin का कोई definite pattern नहीं है, any particular direction में fluctuation हो रहा है. It is changing its position and spin fluctuation altogether is different. So they are independent motion. In that case, in order to calculate the magnetization M and magnetic susceptibility, we will do another mathematical calculation considering their independent motion. तो बजाय म्यूजे को लिख करके, जो कि पहले क्लास में आपको लास्ट क्लास में सिखाए थे, ये म्यूजे को नहीं करके अब जो है independently magnetic moment due to orbital motion and magnetic moment due to spin motion. So nu L is equal to minus of GL E by 2 me into vector L, taking the projection along the Z direction, nu L of Z, and considering only the magnitude part, because the negative sign is only to give you an interpretation that orbital angular momentum vector is opposite to that of the direction of orbital magnetic moment. So nu L of Z, GL has a value 1. This is equal to E by 2 me. LZ is equal to ML into H cross. This is equal to ML EH cross divided by 2ME. So this is Bohr magneton. Now I remember I asked you to check the value and the unit of it. Was I correct? It was 9.28 into 10 to the power minus 24 ampere meter square. So this is equal to nu B, the Bohr magneton, multiplied by ML. Similarly, nu S, this is equal to minus of GS E by 2ME into vector S. So the projection of this particular spin magnetic moment along the Z direction, this is equal to GS, which has a value 2 E by 2ME into MS times H cross. This is equal to 2 E H cross by 2ME. All this multiplied by MS. So this is twice Bohr magneton nu B into MS. So after this, we have got the value of nu L and nu S. All this is calculated in terms of the function, and the discrete function we have to write this equal to summation over ML minus L2 plus L. This is ML into nu B e to the power ML nu B times nu into H divided by KT. This is the distribution function. All this divided by summation over ML minus L to plus L e to the power ML nu B by KT. So this type of situation we have done previously also. There, instead of writing ML, actually you were writing MJ, and there was an additional factor of GJ plus, as both of them are independently present. So this is for the orbital moment. The magnetization contribution from the orbital moment of the electron. Another one from the spin moment. So you have multiplied by 2 because GS has a value 1 and ML has a value 2. mu b e to the power, directly we are liking ms Bohr magneton mu b mu into h divided by k e to the power ms mu b mu into h divided by kt. ms is equal to minus s2 plus s. ms is equal to minus s2 plus s. So independent contribution, the first term, independently the contribution to magnetization of the system from the orbital motion. The next one from the spin motion. And as GL has a value 1, so I haven't written 1 here. You can write 1 dot. And here itself you can write 2 dot. This is GS, as spin orientation can take two possible values, so that's why 2. Here itself, it can take only 1, so that's why 1. And this discussion we were doing considering the case where the temperature T of the system is high and the applied field H is strong. Where T is high and the applied field H is strong. So can we write it like this? Now if you cross verify, what we written here mu into H, we haven't written mu into H.
New B
GJ
into
mu
H.
H divided by KT. So we haven't taken that particular factor of mu itself. So here also you can omit that. That can be taken. Or you can take separately because energy E is equal to energy E is equal to minus of mu J, that is mu L into dV. So there will be an additional factor of mu. If you haven't taken mu, that there you can write here that we have assumed mu is equal to. We can do one thing. We can take. Let us assume. Let us assume mu is equal to 1 unit. Now the magnetization calculation. So magnetization M, this is equal to summation over ML. Now apart from this, this is to be multiplied by capital N. I think we have taken this notation, capital N, where N was the number of atoms per unit volume. Because magnetization, the unit itself says it is increased magnetic moment per unit volume. So N you have already taken the number of atoms per unit volume present in the system. Nu B universal constant. Nu B universal constant. We can take these two factors outside. N into nu B. So it is ML. From minus L to plus L. Now, this also we have done previously itself. E to the power x can be written as 1 plus x because magnitude of x is very small. So can I directly write here ml 1 plus ml mu b. We have taken mu equal to 1. So directly I will write h divided by kt plus whole divided by summation over ml minus L to plus L 1 plus ml mu b 8 divided by kt plus 2 times of summation over ms minus s to plus s. This is equal to ms 1 plus, if I am writing E here, one more thing, just a minute. Energy E, I think I should also multiply here also with E, because energy E is equal to minus of mu s into B. So mu s is equal to minus of Gs E by 2 me into S vector multiplied by V vector, and we have taken the projection along the Z direction. So this is minus Gs E by 2 me Sz ms into H cross. So energy E to the power minus E by kT. That means in the factor of E, there has to be a value of T. None of you said anything. So there also, apart from this two, there will be a two here also. ठीक है? इसमें किसी को कोई confusion है? Shall I continue?
Yes,
Okay,
sir.
fine. So I will wrap this portion. So ms 1 plus 2 ms mu b into h divided by kt, or divided by summation over, here also there will be 2 ms minus s to plus s 1 plus 2 ms mu b h divided by kt. So see, these things also we have previously done. If you remember, this is equal to n times of mu b. What we have to do here? Summation over ml minus L2 plus L. ml into 1 is ml plus mu b h by kt is constant. Mu b h by kt. This is summation over ml minus L2 plus L, and this is equal to ml square whole divided by summation over ml minus 1 minus L2 plus L 1 multiplied by 1 plus summation over mu b into h by kt, summation over ml equal to minus L2 plus L, and this is equal to ml. So after this is one factor. Similarly, we will write it for the other one, plus 2 times of summation over ms minus s to plus s ms plus 2 mu b h divided by kt. This is summation over ms minus s to plus s ms square, summation over ms minus s to plus s dot 1 plus 2 mu b h by kt, summation over ms minus s plus s times ms. So This is the situation right now. Now, average magnetization and simple calculation. The conceptual part was the independent motion of L and S. Why? Because the internal field B becomes ring. Why? Because the fluctuation of the electron cloud was not strong enough to create a strong internal field which could couple, which could attract the orbital motion, which could synchronize the orbital motion with that of the spin motion. And this may be possible for many of the materials. I tell you, right now you haven't done perturbation theory in quantum mechanics. But spin orbit interaction is a very famous perturbation term, and that give rise to additional energy level terms. जैसे आप लैब में काम कर रहे हैं, ऑप्टिक्स लैब में आपने स्विच ऑन किया तो सोडियम लाइट में ऑर्बिट का कपलिंग फैक्टर बहुत स्ट्रांग है. अपार्ट फ्रॉम strong blue yellow light, you may see some kind of faint green light also, or some kind of faint blue light also. And these particular lights, I mean the transition, all these transitions are possible only when there is some additional extra factor. That extra factor which is disturbing the normal transition path. So that is said to be perturbation. Perturbation means disturbance. ठीक है, क्वांटम मैकेनिक्स में बहुत इंपॉर्टेंट चीज है परटर्बेशन थ्योरी. ये शायद आपका सेमेस्टर 7 या 8 में. तो वेरी वेरी इंटरेस्टिंग थिंग. जैसे पोटेंशियल बॉक्स, तो पोटेंशियल इन बॉक्स में आपने इस तरह से पढ़ा है. अब अगर परटर्बेशन रहा तो देखा गया कि इस तरह से हो जाएगा. ये बॉक्स का बिहेवियर कुछ इस तरह से होगा. सो दैट विल ओवरऑल, जैसे पोटेंशियल इन बॉक्स, ground state, wave function first state, wave function second state. You will see that when the situation is like this, then overall there is some modification in the first excited state itself. So overall, this changes the transition levels. So this LS coupling is a very famous thing, and it is not a universal phenomenon to be found out in all type of situations. Anyway, continuing with this calculation, simple now, n mu b times this we have done, summation over ml, this is 0, summation over ml square by kt multiplied by ml square L into L plus 1 into 12 plus 1 whole divided by 3. This multiplied by summation over ml over 1. So that is equal to 2L plus 1. And when you do the summation over ml, this again cancels out. Plus 2 times of this is equal to summation over ns, again 0, summation over ns, again 0. What you get is 2 multiplied by 2 mu b divided by kt square s into s plus 1 into 2s plus 1 divided by 3. All this multiplied by ms from minus s to plus 1 over 1, and this gives you a value 2s plus 1. What extra factors can be cancelled out? 12 plus 1, 12 plus 1, 2s plus 1, 2s plus 1. So the average magnetization M, this is equal to N mu BH by KT is common. in both the terms, nu b h by 3kt. So can I write n nu b square into all this multiplied by this is L into L plus 1 plus 4 times of S into S plus 1. अब जरा आप चेक करो लास्ट क्लास में जो मैग्नेटाइजेशन का एक्सप्रेशन निकाले थे अगर हम यहाँ H से डिवाइड करते हैं मैग्नेटिक ससेप्टेबिलिटी का एम m divided by 8 this is equal to n mu v square by 3kt multiplied by the factor of L into L plus 1 plus 4 times S into S plus 1 और जब आप एल एस कपलिंग को कंसिडर करके कैलकुलेशन किए थे तो ये जो फैक्टर है एल इंटू एल प्लस 1 प्लस 4s इंटू एस प्लस 1 हमको लगता है इसके जगह पे आपका था जे इंटू जे प्लस 1 तो ये डिफरेंस अब आपको समझ में आ रहा होगा कि when there is a strong coupling of L and S such that we can do a vectorial addition of L and S over an average of time to get the value of J there instead of L into L plus 1 plus 4S into S plus 1 what we observe as J into J plus 1 but that is not the case here. The situation has changed. So the experimental discrepancy, the result, what was the change, what was the difference between the theoretical and the experimental results, the material scientists, the atomic physicists of that time were able to overcome that difference by doing an independent calculation, assuming that there is no synchronism, no coupling, none kind of a bonding between the orbital vector and the spin vector. Their motions are perfectly independent of each other. So we get the value of magnetic susceptibility chi m in the form of n nu b square by 3kt. You can see again in the denominator you have t. So you increase t, overall there will be complete disalignment of the magnetic dipole, even in a gaseous system, and it will become an unmagnetized material. So everything depends upon this factor of t and upon this value of h. So you try to change the particular ratio of h by t. Overall, there will be a phase transition in the system. A paramagnetic material will no more behave as a paramagnetic material, will actually become an unmagnetized substance. Now, so this expression can be written as chi m is equal to n nu b square divided by 3kt multiplied by p effective square where p effective square is equal to L into L plus 1 plus 4s into s plus 1. ठीक है? So this is the expression of magnetic susceptibility when L and S are independently moving in an electronic system. Now, if you remember, when we were discussing about classical Langevin theory of paramagnetism, we discussed it for two extreme cases. One was for the case of high applied external magnetic field H as compared to that of the temperature of the system is low. So, in that situation, the things will become very complicated. Now, let me just give an overview. If you can do it at home, then in the next day I will start a new thing, a new discussion with you. We will probably start with a discussion of superconductivity. विलोवन फैक्टर का है, जरा हम देखें कि किस तरह से आप लोग इसको करेंगे, एक बार जरा देख लेते हैं। तो जिस जगह पे हम लोगों ने ये देखो, ये है मैग्नेटाइजेशन का एक्सप्रेशन, ये लास्ट क्लास में ये सब कुछ आप कर चुके हैं। अब जो सिचुएशन आपके सामने है केस 2, वहां पे ये है कि h इज वेरी हाई एंड t इज स्मॉल, सो यू कैन नॉट राइट e to the power x equal to 1 plus x. No, you cannot write it like this. So in that case, what we will do is the magnetization factor, इसको लिखने का तरीका है मैग्नेटाइजेशन m is equal to n gj mu b, पैरामीटर्स में तो हम कोई चेंज नहीं कर सकते हैं, समेशन और mj माइनस टू प्लस j e to the power times mj multiplied by e to the power mj into x divided by summation over mj minus j to plus j e to the power mj into x, और ये जो x है that is equal to gj where x is equal to gj mu b into h, x equal to 1 plus mj, तो हम एक x को एज्यूम किए where x is equal to this. आपका असाइनमेंट रहा, आप लोग सब काफी मैथ्स पढ़े हैं 11-12 से, और जब भी हम कोशिश किए कुछ एक्स्ट्रा क्लास लेने का, हमेशा आप लोग मैथ्स का क्लास का नाम लिए हैं कि आप लोग का मैथ्स का एडिशनल पेपर है। तो हम एक्सपेक्ट करेंगे कि आप ये कैलकुलेशन करके आए, ये कैलकुलेशन किस तरह से होगा, ये कैलकुलेशन अब हम किस तरह से करेंगे। सिचुएशन को समझ गए, h इज हाई t इज लो, तो अब आप यहाँ पे वो अप्रोक्सीमेशन नहीं कर सकते हो कि e to the power mjx is equal to 1 plus mjx. No, this is wrong. You have to take it as it is. और आप ये भी नहीं बोल सकते हो लिमिट ऑफ एक्सटेंडिंग टू इंफिनिटी, तो कहानी खत्म, दिस इज इक्वल टू इनफाइनाइट, देन देयर इज नो पॉइंट ऑफ डिस्कशन। तो ये कैलकुलेशन हम आपसे एक्सपेक्ट करेंगे, अगर आप इसको कर पाए तो नेक्स्ट क्लास में हम लोग न्यू टॉपिक को शुरू करेंगे। एक कि सभी लोग प्रॉपरली अपना नाम और अपना रोल नंबर लिखेंगे। ये अटेंडेंस शीट बार बार बोल रहे हैं कि ये अपलोड होगा आपके सिस्टम में, और अगर किसी को कोई उस तरह का प्रॉब्लम है किसी पॉइंट पे, तो आप मुझे टेक्स्ट भी कर सकते हो व्हाट्सएप में, भी इंस्टेंट हम जवाब ना दें, लेकिन आपको आपके क्वेरी को हम रिजॉल्व कर देंगे। और कितने लोग कोशिश करेंगे, हाउ मेनी ऑफ यू, यस प्रेम, आर यू देयर?
Yes, sir. Yes, sir. Yes, sir. I'm here, sir.
और बाकी आपके सीआर कहाँ हैं?
Hardik.
So I will be expecting you to solve this particular situation. ये अगर आप लोग कल सॉल्व करके आए तो कल नया टॉपिक शुरू होगा, और नहीं तो फिर हम इसको सॉल्व करेंगे, देन वी विल स्टार्ट अ न्यू टॉपिक। ओके देन,
Yes, sir.
थैंक यू।
Thank you.
Yes, sir. Thank you, sir.
Yes, Palak, you want to ask something?